Welcome everyone. I am Pabido Macmillan. Let's begin. Applications of numerical methods in train and traffic networks. Introduction. Mathematical modeling of traffic flows began to develop from the middle 20th century and today is being increasingly improvement due to the rapid development of big cities and the infrastructure and a growing number of vehicles per capita. In the development of the theory of traffic flows was formed two main approaches to this problem. The macroscopic, which considers the traffic environment as something whole, usually as weakly compressible liquid, and macroscopic, considering every vehicle as a single pa- particle with its speed and the final destination. In this paper, mainly used numerical methods of microscopic simulation. Computer simulation methods are universal because they allow to calculate numerical methods models of any complexity. But often these calculations require the use of large computer capacity and therefore not always suitable for real-time control. For more flexible application, simplify conditions are used, including reducing the problem to a single line microscopic modeling. But the calculation of specific values and derivation of empirical relationship requires the microscopic simulation. What is numerical method? A numerical method is a complete and definite C procedures for the solution of a problem. Together computable error estimates. The study implementation for of such methods is the provide of numerical analysis. Numerical methods. It is improvement to recognize under what conditions a method can be followed and what starting value to choose from in order to ensure that the chosen method small work converge. Numerical methods can be used for finding roots of equations, bisection method, Newton raptions, fixed point iteration, etc. Solving ODEs, a Euler method, improved Euler, RK methods, midpoint method, predictor, finding values of integrals, midpoint, trapezoidal, Simpson's value, interpolation, Lagrange interpolation, Newton interpolation, spline interpolation, and etc. Types of numerical methods: Bisection method, Newton Raphson method, iteration method, Newton's forward interpolation formula 5, Newton's backward interpolation formula, Gauss-Seidel method, curve fitting. Applications usually used in computer science for root algorithm. It is used to determine profit and loss in the company. Used for multi-dimensional root finding. Solving practical technical problems using scientific mathematical tools. Network simulation, train and traffic signal. Weather prediction, build up a algorithm. Dynamic model of train track bridge with the performance degradation. This section provides a concise and precise description of the experimental result, their interpretation, and the experimental conclusions. Physical mode, train model. The subsystem model of fridge trains is divided into two parts: DF11 locomotive and C17 carriage. The subsystem model of the passenger train is divided into two parts: DF11 locomotive and YEZ25B carriage. In this model, the C17 carriage of the fridge train and the YZ25B carriage of the passenger train have the same physical model, but there are differences in the locomotive mass and wheelbase. The subsystem model of the fridge trains is divided into two parts: the DF11 locomotive and C70 carriage. The DF11 locomotive is a six-axle locomotive model. It consists of a car body, two forms, six wheel sets, a total of nine rigid bodies, and a suspension system of one and two suspension systems. Track model. The ballast track, which consists of the rail, fastener, railbed, sleeper, and ballast, is modeled as a discretively supported three-layer system that considers the degrees of the rail, the sleeper, and the ballast. The rail is treated as a continuous Bernoulli Lewis beam, which is supported by discrete points of spring and dampers that represent the elasticity and damping of the rail bed. The sleeper is represented by a rigid beam, and the vertical is considered. The ballast, ballast bed is replaced with the equivalent rigid ballast body, in which only the vertical motion is taken into account. The edge elastical contact model is used to calculate the track irregularity and the superposition caused by the change in the beam safe is considered. Bridge model. A finite element model of a simply supported beam bridge with a span of 16 meter is established. The finite element model of the bridge considers the three sections of Zintai railway. No 40 bridge. Three types of beam sections are established in the model. The polygonal section at the beam supported and the 1 divided by 2 and 1 divided by 4 section of the beam. Other T sections at the cross section are considered. The pier is a circular beer with the following dimensions. The main 118 space beam unit is used for the upper beam body and the fire of the bridge. The horizontal and vertical stiffness of the roper blade bearing is modified between the bridge beam body and the bridge pier. Computer microscopic simulation of traffic at the signal controlled road intersections. Description of the used model. In this article, we are considering model constructed by authors which generalizes Triper's model to the case of multi-line roads. Considering in 2,3, in the model each car will have a desired speed from 0 to same value Vm max. The value d is distance between the current vehicle and the next vehicle in front of it. Update rules are set by Draper's model. Acceleration in IDM model is a continuous function that takes into account the different models of driving of all speeds in road as well as in urban traffic. In addition to distance between the vehicles from bumper to bumper and the actual speed v, the model also takes into account the difference between velocities. Acceleration function is the model is determined by the formula for in this expression the strategy of acceleration on the free road. Vf re omega equal to a into 1 minus v divided by v omega 0 comma combined with the strategy of deceleration braking v break sp s comma v comma del omega equal to minus a into s divided by s into t into do, which become prevailing when gap between vehicles cases to be much larger than the effective deserved gap s into v comma delta nu. Same result in the simulation signal controlled road intersections. Let's review the road intersections featured in the article with the defined heterogeneous flows which next traffic lights bases. For example, the first base means that for the vehicles driving on the lower and road a turn right is allowed, and for the vehicles driving on the left road, movement in any direction is allowed. For the rest of the vehicles, movement is prohibited. By varying the duration of traffic lights modes, we can increase the capacity of the road intersections. That is to increase the average number of cars crossed the cross in 1 second. The results lead to the following conclusions. The same length of all traffic light spaces does not provide the maximum bandwidth. In addition, the mode 1 allows crossing the road intersection vehicles moving along the direction of maximum input. However, a significant relative increase in the duration of the base does not lead to an increase the capacity of the intersection. Compare lines 1 and 4. For each of the directions of the intersections, many computational experiments was performed. We calculate grid values 5 into 5 into 5 into 5 with duration of each base are 13, 45, 60, 75 and 90 seconds. Computational experimental was performed for 6200 and 625 different traffic lights combinations. Modeling was performed 10 times for every base combination. The mean value of placed into the final table. Thus, the following shorter table was made. The accurating data was investigated for stability in case of incoming flow variance. Numerical calculation traffic at road intersections, the uneven distribution purpose. Also, a real intersection between Ural Kaya Street and Krupskoy Street from Perm City is in Russia was investigated. Statistics on incoming flow intensity and vehicles goal distribution was obtained represented a traffic scheme on the intersection. Morning rush car data was used on this scheme opposite to the perceived problem. The targets are not evenly distributed base scheme of the T-shaped intersection. The intensity of the traffic during the morning rush hour. It was decided for the problem to calculate the optimum distribution of the bases depending on the traffic of the mean incoming flows. The solution of this problem would help to create intelligent control traffic lights modes, focusing on statistical data flows moving in each direction. Each grid point was calculated 60 times. Average values are placed in the table. The optimal length of traffic light bases in 30 seconds for the first base, 90 seconds in the second base, and 30 seconds for the third base. Variation between the best and the worst variant is 35%, which is 914 vehicles per hour for the given flows. Thank you.